All right, let's take a look at question 34. It says the sum of two numbers, x and y, is more than 8. When you double x and add it to y, the sum is less than 14. Graph the inequalities that represent this scenario on the set of axes below. Okay, so part one is to graph a system of linear inequalities. So let's take a look at the two equations. So equation one, we're going to do that one in green. The sum is more than 8. So we know what inequality more than represents. More than is greater than. Okay, there's no equal there. It's more than. Sum operation is sign, is plus. So the sum is more than 8. So we have x plus y is greater than 8. Okay? All right, so this is the first equation. Now, the second equation is tells us that when you double x and add it to y, the sum is less than 14. Okay, so less than, that inequality is just less than, and then we know addition is to add, is plus, okay? All right, so there you go. So we're gonna graph both of them, all right? So let's start with equation one. Let's look at one, x plus y. Now, when you're graphing linear inequalities, you always want to put it in slope-intercept form because it helps you determine the right direction to shade. Okay, so let's go ahead and do that. We want to get y by itself. So we subtract x from both sides, and that yields y is greater than negative x plus 8. In order to graph the line, we need the slope and the y-intercept. Okay, so there's a 1 over 1 here. So the slope m is negative 1 over 1. So we're going to rise negative 1, which is a fall, and we're going to run 1. And our starting point on the y-axis, where you begin, is positive 8. Okay, that takes us to the second point that defines the line with this linear inequality. Since we have greater than, we're going to shade up. And since there's no line underneath, it's going to be broken. The line will be broken and you're going to be shading up. All right, let's go ahead and graph the green line, and then we will proceed to graph the blue line. All right, so set up our system, our coordinate system. All right, so let's see. We are going to start by, let me label my axis. This is y, this is x. We're going to start by graphing the y-intercept, 8, 1, 2, 3, 4, 5, 6, 7, 8. Bam. All right, put a point here. So you're going to rise negative 1 and run 1. Bam, that's 1 point. Could do another one. So this line right here basically defines the first line. So let's go ahead and graph that line for you. Something like, oops, change that. Okay, so there goes the first line. So it's broken and we're going to be shading greater than. So the direction of the shade will be upwards. Okay, so we're shading up. So put the arrow. The reason why I'm not shading right now is because we have two lines that we're going to be graphing, and I will just use the arrows to find the exact quadrant that I will be shading. Okay, so don't shade there, just put the arrows. What this basically means is this entire region below the line should be ignored. Okay, the solution region is the set of points above this line, just for this one, okay? And then the other one will have its own condition, and then we just unite both of them together to find the solution region for the system of linear inequalities. Okay, so let's take a look at the second one. We have inequality 2. 2x plus y is less than 14. So for this one, we want to get y by itself. So we go ahead and subtract 2x on both sides. Subtract 2x, and you have y is less than negative 2x plus 14. All right, to graph this, we need the slope and y-intercept. M is the coefficient of x, -2/1. So we're going to rise -2, which is a fall, and run 1. Rise over run for your slope. Your y-intercept, B, is 14. So these are the conditions to graph the 2 points that define our line. So let's go ahead and do it. Start from 14, so counting from 8, 9, 10, 11, 12, 13, 14. We're going to rise -2, 1, 2, and run 1. Okay, and then we're going to go ahead and graph our line. Okay, so there goes the line. And then we, let's see, we have less than, okay? So what does that mean? Since we just have less than, that means that you are going to shade down for less, shade down, and your line will be broken also, okay? Because we don't have a line of inclusion there. So since that line is not there, our line will be broken. What the breakage of the line basically means is that any point that falls on this line should be excluded. It is not included in the solution region. Okay, only the points that lay below this line are part of the solution region. Okay, so where is the answer to this system of linear inequalities? Let me make it a multiple choice. A, B, C, D. Where do you think the answer is? The answer is the region where both arrows are pointing to. If you look at A, only the green arrow is pointing to A, so that's a no-no. D, none of them are pointing there. C, only the blue arrow. Look at region B. What do you notice? Both arrows are pointing to this region, so guess what? That is our solution region, okay? The boundary points are excluded here, so just shade right here. Bam, 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 bam. So this is the graph of the scenario that represents the system of linear inequalities. This is 2x plus y is less than 14. And then this is the first equation, x plus y is greater than 8. Okay, now let's look at the second part of question 34. It says, Kai says that the point 62 is a solution to this system. Determine if he's correct and explain your reasoning. Okay, so all we just have to do is graph the point and see if it falls into the solution region. So let's graph the point. 6, 2, 1, 2, 3, 4, 5, 6, and 1, 2, bam. Okay, so this is what this Kai claims that this point is in the solution region. So what do you think? Is he correct or is he wrong? Well, Kai is wrong. Why? Because these two lines are broken, which indicates exclusion. Okay? Any point that falls on the line must be excluded from the solution region because the lines are broken. So let's go ahead and write it down. Kai is wrong because the point 62 falls on broken lines which represent points that should be excluded. Okay, there's a reason why it's broken. Broken or breakage means exclusion, which represent points that should be excluded from the solution region. Okay, to be specific, these are boundary points. Okay, boundary points that should be excluded. Boundary points. So the boundary sometimes could be included, the boundary sometimes could be excluded. In order for the boundary to be included, that line must be solid. Okay, and when you have intersection of a solid and a broken line, what you have is a scenario where it satisfies one, but it doesn't satisfy the other. So combining them as a system, it doesn't satisfy the system as a whole, just only one. Okay, so you need to have two solid lines in order for a point that falls on your intersection to be part of the solution region. In this case, you have a double violation. Both lines are broken. So the points that falls on those two broken lines is not a solution. It should be excluded. All right, so there goes.